after the two observations, can I conclude that I have in some sense proved the presence of atmospheric pressure? Do you agree?
Yes, sir.
So atmospheric pressure, you told me that you don't feel it because of your internal blood pressure, but with the help of this activity we have been able to prove that the atmospheric pressure is present. That's why I required a larger force. Now can you measure it with the help of this range? I'll give you 2 minutes to think upon it. Can you give me some way so that I can measure this atmospheric pressure? Any idea comes to your mind, you can share it with me. Don't be afraid that idea is going to be ridiculous or something like that.
No idea is a bad idea.
The ideas are never ridiculous.
When
Yes?
pressure is there and we pull this, it does not just come back. And when we are using the thumb and there is no pressure in it, then it just comes back.
Yeah, that I agree. That I totally agree with you. But that I have already done. That only ascertains the presence of atmospheric pressure. I want to measure this. I want to measure how much is the pressure.
So, but the values to the calculator, the force we applied on the area, if you know.
Okay, if I want to find pressure, I need to know two things. With how much force you pulled it out and what was the area of the system. Is that okay?
Yes, sir.
So I think finding the area of this range is not a problem. I have already calculated it and you can note it down. Its radius is 0.6 centimeter. So I think the information which you require to know the area, I have supplied it to you that the radius is 0.6 centimeter. It's a circular from one side. So I think you know the formula to find the area of the circle. What is it?
Pi r square.
Pi r square. Okay, can you find out the area now? But I want you to find it in meter square. You can use the value of pi as 3.1.
So can we take 22/7?
So we are doing 22/7.
Okay, you can do it with 22/7. Has anyone got it yet? So the area is 22/7, 0.6 into 0.6. Is it so?
Yes, sir.
But what more you need to convert it into meter square? Upon 100 into 100. So can I get rid of this decimal by making it 1000 and 1000?
Yes, sir.
So that leaves me with 22 into 36 by 7 into, can I write it as 10 raised to the power minus 6?
Yes, sir.
So this is what I have got. I leave it here because I have to make some other calculations, and sometimes the digits on the numerator and denominator, they have a tendency to cancel out themselves. So let's not solve it further. Okay? Now the problem is how to find the force. You can only compare the force for a smaller and a bigger fringe. Do you have any idea to measure it? Okay, if I say that you have this with you, have you ever seen it?
Yes, sir.
What is it?
Spring balance.
That's great. So it is a spring balance. If I say you have this with you, can you now measure the force to move the piston by a little amount? So what should I do? You see, I'll deliberately put a hole in this switch so that this hook of my spring balance goes into it. Okay, now please zoom it on me, zoom it on the separators. So, if I try to pull it out the way you have been doing it, the reading of the spring balance should give me the amount of force with which I was pulling it. Okay? So it's very simple. So if I try to pull it out, you see whole of the spring balance, it basically has a reading from, please zoom it in. Dr. Rakesh?
Yes,
Can you do it?
I'll do that.
From your end?
Sure, sure.
So I want you to zoom on the scale of the spring balance. Yes, a little more, little more. Are you able to see the scale now? It reads from 0 to 1000 and that is in grams. Okay? I have exhausted the whole of the scale, but the syringe is not coming out. So it means the force which was required to pull it out is greater than this force which can be measured by the spring balance. So what should I do then? Should I go for a bigger or a spring balance with a larger scale?
Yes.
But what if I don't have it? I have two such spring balances. Can I solve my purpose?
Yes.
How?
You can attach both of them. Yes, sir.
Should I attach them like this?
Yes, sir.
It's not going to solve my purpose because when the springs are in series, their effective spring constant reduces. Both of them will read equal amount of reading. So what should I do?
How about
2 is better than 1. That's true. But they are of no use if I join them in series, end to end. Let's see, if I join them like this, what would you call this combination as? Parallel combination? So, I think it's if the two persons are pulling at the same time, they will be providing the larger force. Let's be logical about it. So I have to join them. I have a thread here. Actually, the spring balances, I think and I hope that they are available in your lab.
Yes, sir.
So then I have not supplied these spring balances to you because I want you to repeat this activity in laboratory. You will be allowed to retain the syringes you have with you. I think they will be given to your teacher, and this is an activity which you will be required to perform in lab. I'll show you how. I have just a thread and I have bundled them in layers so that it becomes a little stiffer. So what would you do? That you will tie these two springs together. I'm not trying to use anything which will be not available to you. Now, this thread is available to you in the laboratory because you must have performed the experiment on a simple pendulum. Have you ever seen a simple pendulum?
Yes, sir.
In your laboratory?
Yes, sir.
What kind of device it is? It uses a thread It uses a thread, so you can use the same thread which is available in your laboratory. So what I have done here is that I have tied them together, and let us now try to see that does it solve my purpose or not. So I'll put a little knot here just so that I can attach it to the back of the switch. Are you getting what I am trying to do?
Yes.
The purpose is to pull this switch out with the help of two spring balancings at the same time. So that is what it is. Can you get my... That's I forgot to say that. Must be no. So the initial reading is like 100 grams. That must be the weight of the two spring balances combined. Now let's see if it happens or not. So now I have been able to pull them out. And if you can focus on the reading, this is around 750 grams. So 750 on your side, 750 on my side. So you don't have to pull it completely out. You just have to pull it out by a little amount. You see the piston of the swing is coming out of its cylinder. As soon as it starts coming out, you have to take the reading. And reading with me here is 750 grams. But I had an initial reading also, and that was 100 grams. So now I can have force with me. Force is 750 minus 100, 13 grams, 650 grams, but this is for one spring balance. Okay, it's on both sides. So what I'll do, that the force will be twice of it. Can I write it as 1.3 kg? 650 plus 650 makes 1300 grams, and that comes out to be 1.3 kg. Okay? Now, should I use it as such, the force? Let me write it as kg weight. I want to find the atmospheric pressure in the units which are the SI units, or the units which you are familiar with, and those units are Newton per meter square. What do you do to convert kg weight into newtons? What do you do? Yes, speak up. Someone was whispering and I have heard it, and the answer was correct. Akshita. Yes, multiply it with the 9.8. What is 9.8? I hope it's the value of small t. Okay. I think I go for the easier option. I multiply it with 10. That's okay. That much of approximation is okay. Normally you use G equal to 10 in your numericals. So then F comes out to be 13 newtons. Is it okay? I multiply it by 10. Now can you try to find the pressure now? You know what you wanted to know. That is 13 Newton upon 22 into 36. I'll take 7 in the numerator and it is into 10 raised to the power 6. It was in the denominator 10 raised to the power minus 6. When I take into the numerator it will become 10 raised to the power 6. Is it okay?
Yes, sir.
This is the area, beta. And when you write whole of this thing in the denominator, it will become 10 raised to the power 6. So can it write, say 10 raised to the power 5 and I can make it 70?
Yes, sir.
So it is 910
Yes.
upon
Yes, sir.
how much it is?
720.
Can you do it for me?
Yes, sir.
I hope it comes out to be 792.
Yes, sir. Yes, sir.
If you 10 raised to the power 5. Okay?
Yes.
So, how much it is going to be? Okay, I'll make it easier for you. You can make it, you can always make the little approximations. I'm not trying to find the exact value of atmospheric pressure. With the help of this little activity, I'm trying only to approximate the atmospheric pressure. And if I'm allowed to say make it 790, this goes off. I'll make it 90, this as 80. So 9 by 8 into 10 raised to the power 5. That with something like 1.01 into 10 raised to the power 5. This is the value of P atmospheric. Do you know what is the exact value of atmospheric pressure? It's 1 atmosphere. How much is 1 atmosphere in terms of Newton per meter square? How have you calculated the atmospheric pressure in your class, in your theory section? HOG, you know that? That's very encouraging. So, P is equal to HOG. That is how you do it.
No, they said something else.
Experiment by which you do it?
What did you say?
My H goes here. H rho G. Rho is the density of mercury. Okay. I'll take D. Basically, in higher physics, you use the letter rho. It's from Greek alphabet. So HDG. Now the value of H happens to be 76 centimeter. Can I write it as 0.6 meters?
Yes, sir.
The density of mercury happens to be 1306 kg per meter square. Is it okay?
Yes, sir.
And value of G 9.8 meters per second square.
Yes, sir.
So that is how you have calculated the atmospheric pressure. What was the name of the experiment by which you did it? Was it by any chance Torricelli's experiment? It was Torricelli's experiment. It was Torricelli who calculated atmospheric pressure by inverting a mercury tube and in a mercury tub. Was that so?
Yes.
Okay. And if you will calculate it, the answer will be 1.05 into 10 raised to the power. And what have we got? Oh, that's great. So, luckily, our answer and Mr. Torricelli's answer match with each other. And people only believe Torricelli. So at least we have been able to calculate the atmospheric pressure with the help of a 5 rupee syringe instead of a 5,000 rupee barometer. So this is a barometer for you.
Isn't that interesting? Okay.
Have you liked this barometer?
Yes, sir.
Not looking as smart as the actual one, but at least it has solved our purpose.
Yes.
Okay?
Ask him. Akshita wants to ask something.
Yes, Akshita. Yes, do you want to ask anything?
No, sir. No, sir.
Were you expecting anyway this excellent match between the two readings?
No, sir.
Okay, one thing more. If you will repeat the same activity which I performed here in your laboratory, would you be able to get a lesser pressure or more pressure? Would the reading at Missouri will be more than this? Or by all the calculations?
Less.
Why? Yeah, because Missouri has a greater altitude than Chandigarh. And atmospheric pressure decreases with height. Why does it happen?
Density becomes rarer.
Okay. Then I will go deeper into it. Why the density decreases, I think we should leave it. Now, we have been able to establish with the help of our activities that the atmospheric pressure is present, and we have been able to calculate it with the help of a little activity. Now I have one more thinking. What are they saying?
Yes, sir.
Okay, I have two bottles. Please focus on this. I tell you what it is. Don't be so curious. Yes, zoom it only on these two bottles. On to their bases. Yes. You see, I have a pipe connected between the two bottles. I have joined the bottoms of these two bottles. Okay? What do you expect when you join the